So in this question we're going to use a chi-squared test to determine whether there is any association between two variables. The context of this question is whether people who live in a different area would prefer money to be spent in a different way. So the first step is always to state the hypothesis. So H0 is always that there is no association between the variables, or that the variables are independent. So in this case there is no association between area and preferred spend. And that means that H1 is always that there is an association, or the variables are dependent. So there is an association between area and preferred spend. The second step is just to state the significance, so we are going to do this question at a 1% significance level. Now, if there's not row, columns and totals on the table that they give you in the question, you should really add these on. However, you don't need them if you're going to do this on your calculator. We're going to draw up a table. Now, the table that we've been given in the question are all the observed values. So these are called O. So the observed values are 156, 216, 144, 135, 120, 108, 60 and 81. We also need the expected values. Now if you need to do these by hand, you work out the expected values by doing the row total times by the column total divided by the grand total, so the total of everything. Now your calculator will do this for you, but if it was a show that question or they put some algebra in, for example, you do need to know how to do this. The third column is a column of the observed, take away the expected values, squared, divided by the expected. And again, your calculator does actually work this out. And ultimately what we want is the sum of these observed, take away, expected values. So I'm going to start by doing this on the calculator. If you go into your calculator and into the stats mode, you want to select test, then chi, and for all the questions that we're going to do, it's always a two-way test. So you should end up with a screen like this. So you've got observed is matrix A, expected is matrix B. So we need to type in the data that we're given. So if you select the one that says matrix, so it's the one with the little arrow next to it, F2, you should come up with a list of all the different matrices you've got. So in matrix A at the moment it says none because we've not put the data in. So we need to click dimension. This is where we're going to tell it what dimensions our matrix has got. So if you click on that, it comes up saying M times N. So M is the rows and N is the columns. So in this case we've got 2 rows and we've got 4 columns. And it should come up with a matrix on the screen. So we are going to type in the information from the question. So I've got 156, 144, 120, 60, 216, 135, 108 and 81. Because the calculator is going to work everything out based on these values that you've typed in, you must check you've done it correctly. So once that's all typed in, you can just press exit and exit again until you return to the chi-squared screen. Okay. Now if you now press execute at the bottom, it will perform the test for us. Now this first value that comes up here is our chi-squared value, which is also the value that goes at the bottom. So it's done all this working out for us. So the chi-squared value that we get is 10.233. So I'm going to do it to 5 significant figures. So this value here is the chi-squared value, or we also call it the test statistic. So this has just come from the calculator. The other thing that we might want from the calculator is the degrees of freedom, which tells us it is 3. So I'm just going to note this down here. So the degrees of freedom and usually would use V for degrees of freedom, so I'm just going to write down V is 3. Again, if you needed to do this by hand, if it was a show that section, then you would do whatever the number of rows is, take away 1, times by whatever the number of columns is, also take away 1. Now, we do need some more working out than this because they need to see some of this table completed. So even though the calculator has actually done the value for us, if you press matrix here, which is F6, we need to get the expected values. So the expected values have gone into matrix B. So if we select that and press execute, you'll see a table of expected values. Now we need to make sure that these are matched up with the correct values in the table. If you're unsure and think you might get it in the wrong order, the easiest way is just to scribble them onto the table at the top first. So for example 156 has become 175.06. And then copy them onto the bit at the bottom. What you must be careful of then is that the screen at the top here, it doesn't actually round them for you. So if you look at the top it says 175.05. Actually if you look at the full version at the bottom, if I round that, that's 175.06. So you must highlight each value as you copy it so that you get the full thing. If we want the final answer to 3 significant figures, then we'd need our working to at least 4. Again, if it was 1 decimal place, we'd need our working to at least 2. So make sure you highlight each of these values and get enough significant figures. So in this case, I'm going to do all mine to 5. So I've got 175.06. And then if I go down, I've got 196.94. Now I've done it in this order, so I've got 131.29, but you must make sure they're matched up correctly. And then just copy the rest of them down. So once we've got all our expected values, they do need to see that for method marks in the exam. You've also got this last column that's O take away E squared divided by E. Now, again, your calculator's done this for you. I wouldn't work them all out, but you want to show the exam that you do know how to do it. There's often a mark for this. So I'm just going to put a few of them as an example. So the first one, if I did this, I would do 156 take away 175.06 squared, all divided by the expected, which is 175.06. And if I work that out on my normal calculator, I get 2.075. Again, the second one, I'd do 216 minus 196.94 squared, all divided by the expected, which is 196.94. And this on my calculator gives me 1.845. Probably a good idea to do 3, just to show them that you do know exactly what you're doing. However, I say your calculator has already worked all these out. So the next one would be 144 minus 131.29 squared divided by 131.29, which gives us 1230. I'm just going to put ... That happens all the way down, but you don't need to work them out. The value of chi-squared that we found at the bottom from the calculator has been done by working all these values out and adding them up. The next thing we then need to do is we need to get the value of chi-squared from the tables or from the calculator. So this is our test value. We need to get our actual value. So we've got degrees of freedom 3. The easiest way to do this on the calculator then is to go back, press exit a few times to get back to the normal stats menu. The distribution we're using then, so you just click F5 for distribution, select the chi distribution, and we want inverse chi, so again this is F3. So the variable, it should always say data variable at the top, then the area that we want underneath, and then the degrees of freedom. And if you press execute, it will work out the value for you. This bit at the top tells you that it's just thinking about it. So we've got then that our chi-squared value, if degrees of freedom is 3, is equal to 11.345. 5. Okay, so again, I'm doing it to 5 significant figures. So again, if you go back to it, the area comes from the significance level, so in this case 1%. The degrees of freedom comes from what we've done when we've done the test earlier. So you must make sure that they are correct for what you're doing. If you want to do it, if you prefer to do this from the tables, then if you're doing it on the tables, you'd look up 0.99, degrees of freedom 3, and again it would give you 11.345. So you can either do this from the tables or you can do it on the graphical calculator. Now we need to compare these two values to decide whether we're going to accept or reject H0. Probably find it easiest to do it on a diagram. So if I sketch my chi-squared curve, a bit like this, my value from the tables was 11.345. This gives me my critical region. So in this area here, I would reject H0. And in this area here, I would accept H0. I then want to draw my test statistic onto this diagram as well, so 10.233, so that would be around, say, here somewhere. And I can clearly see then that because 10.233 is in the accept region, that we are going to accept H0. So we'll do that whenever it ends up in that region. So my final thing to do then is to make my conclusion. So I'm going to accept H0 at a 1% significance level. And the final comment must be in the context of the question. So evidence suggests that the area people live in is independent, or there is no association of how they wanted the money spent.